Okay, we'll go ahead and get started. This is the third and final webinar of the day. Today we're joined by Florian and Yusuf. Yusuf is a solutions architect here at Linbit and is responsible for testing a lot of our software, writing documentation, creating videos, and helping customers figure out what the best product is for their project. We also have Florian, who is from IBM. He's a senior enterprise IT architect. Today they'll be going over OpenShift and LiNBIT SDS integration.
Okay. Should I start?
Yes, please.
Yes, okay. Please. Perfect. So I was told a small challenge. So if I have a company or any kind of workload, the challenge would be, well, where would I run my workload as a company really in a rock solid way, which means with no outages, no bottlenecks, and no security issues. And that sounds maybe a little bit fancy and yeah, not achievable, but I want to show you something that does that. So let's put this three part of the challenge. So no outage. Can a system really do that? Well, if we talk about no outage, we mean obviously availability. So to have availability, I really need a rock solid hardware. So a hardware that does not fail, that has zero outages. And well, there is a system called LinuxONE that really has a mean time between failures that is measured not in months, not in days, not in weeks. Well, it's measured in decades. And that just shows, well, this is really rock solid hardware. And it has no single point of failure. No matter where you look into the machine, into the hardware, it has no zero point of failure. And there is a IDIC report that just shows that. If we talk about LinuxONE, there's also an equivalent of the hardware specs itself, which is called IBM Z or Z systems now. And you can see this in this report here, which shows the systems with the lowest downtime percentages due to successful security attacks, which is 0.3%. It is nearly nothing comparable to all the rest of the world outside there. And there's another one that has, well, the fewest successful data breaches, which points more to the security of the system itself. But you can see here, there is zero successful data breaches in those systems. That just showcases, well, this is rock solid hardware. How do we do that? Well, we have something you all that are known of RAID, so redundant array of independent disks. We have the same for memory. So we have 5 DIMMs. We have a RAID 5 over that. So there is redundancy also in a DIMM array, but on the DIMM itself, we have error correction, SRAMs, and for the DIMMs itself, we also have spare lanes that if we measure some failures on a lane itself, we can switch it. So we really build everything about redundancy and rock solid hardware. But we do not stop there. So we have redundant memory, but we also have now a level 2 cache, wipeout error correction and sparing. And because we do everything on this LinuxONE systems virtualized, we only have virtualized resources that can never fail, because a virtualized CPU, you just put it onto another hardware resource, and we have really enough of that. So this is another thing why we really can say we have no outage. So we have our spare CPUs, and all those features are available on those two systems, IBM LinuxONE and IBM Z systems, or previously in the previous generations, we call them just IBM Z. So this is really a rock solid hardware that have you, have reach the goal of availability or zero outage. So overall machines that are installed worldwide, we have an unplanned downtime of 36 seconds a year. So if someone has 5 minutes of an outage, it means that 20 other systems have never seen any outage. So yeah, this is really rock solid hardware. And I would say, whenever you have a workload that is critical to your business, it should be on those machines. But the second challenge, no bottleneck. Well, if I put everything on a machine, is there a bottleneck? Well, what we mean with that is not only we need scalability, because yeah, your system is increasing, decreasing, it lives and breathes, and you should have the ability to just use more hardware and also reduce it. So scale out and also scale up in one machine or one footprint. This is quite good, because well, if I have one footprint and I can scale out, so increasing the number of instances, and also scale up by just making the instances bigger, that's the best case you can have. And we also know we need DR capabilities, and also need the ability to handle spiky workloads that, yeah, normally happen sometimes. Well, with those LinuxONE systems, we have 190 CPU cores. It doesn't sound that much, but if you compare it, those are an equivalent of about 1,900 Intel cores installed on a system. So it gives you more what this machine really can handle. It's also the highest frequency on a processor with 5.2 gigahertz. And we have 40 terabyte of this RAM memory available in one footprint. We have really capacity backup, which means you can on the fly increase the capacity you need for your system. And just to see, we can handle spiky workloads. One single footprint, one single machine can handle 30 billion secure transactions a day. To comparison, Google searches are worldwide 5.6 billion. So we can have, yeah, nearly five Google searches a day processed on one system on one day.
Yeah, really impressive.
Absolutely. So that's why we say with LinuxONE, we really can scale up and scale out with 2,000 virtual machines and nearly 2.5 million containers, and not only, yeah, small containers that just running a hello world transaction. No, really containers that handle databases and all those stuff. So as you can see here, this is a modular system. It can fit from one footprint to four racks. Those are all those configurations are one machine, but the whole CPU and RAM configuration can fit into the second rack here. So the 2-rack option, this is what handles then all the CPU power you need. And the third and the fourth rack are just needed if you have really more I/O configurations that are plenty available here. We can do all the stuff by having additional accelerators, for example, for encryption or sorting in each and every of those 190 cores. But we also have compression and in our current or new released machine available, also an AI accelerator built into the hardware to handle all the workloads just without any bottleneck. Third part of our challenge, no security issue. Well, we had the fewest successful data breaches just shown in the chart before. But what we also need is really a workload isolation. So if we have customer A and customer B on the same machine, which has the capability here, well, they should not see each other. And we can really achieve that. And also, if we want a secure system, we need to talk about encryption for data in transit, data at rest, and data in use, which means confidential computing or a trusted execution environment. And for sure, a certified hardware security module, so HSM. Well, we just have all of those points in our LinuxONE systems. The fewest successful data breaches, I just showed them in the IDIC report of 2021. We have a workload isolation, which is EAL5+ certified, which means it is as secure as having a separate hardware environment. Well, for sure, we have 100% of network and also storage encryption, all accelerated by separate co-processors. We have data at rest, 100% on all volumes or file levels, also with our accelerations. And we really have a confidential computing environment capable of up to 16 terabyte, which means that, yeah, you can put your whole application landscape currently, put it into one confidential computing environment and just run it unchanged. And that is just impressive. And the hardware security module, well, there is a FIPS 140-2 level 4 certification standard. And guess what? We as IBM are the only in this world that have achieved level 4. No other has done this over the last, I think, 2 decades. So yeah, we are the only one that really, if we talk about security, we really mean that. So all of this is available on-prem, or you can also have an instance of those LinuxONE machines in IBM Cloud. So you can start with that in the cloud and then go on-prem, or do both, no matter. We are capable of all of that. So the challenge was, is there a system that really can run your workload rock solid? Yes, it is. IBM LinuxONE. And it is really an I/O monster. But even an I/O monster needs some kind of storage. And with all those facts now that we have heard about LinuxONE, well, Yusuf will tell you now something, how this really can go further in the pipeline.
Thank you, Florian, for explaining LinuxONE again. I mean, it's always great to listen to LinuxONE platform. And to be honest, personally, I really like the platform itself. And I have been working with IBM for so many years now, before even Linbit. And I know how IBM actually takes care about security and rock solid hardware. I have been using IBM machines for so long time. So this whole platform is actually really excited for me as a solution architect that was a system admin back then. So yeah, okay. So I will I will try to explain the Linbit SDS here, the software-defined storage that we managed to create a partnership with IBM. And we built the Linbit SDS for the open source world. It consists a software, what we called a LinStore, and the replication part is handled by the DRPD. And the DRPD is a replication technology that is working in the kernel itself, the Linux kernel itself, while the LinStore software manages the replication, replicated disks, creates them, upgrades them, expands them, or shrinks them. And LinStore also has the seamless integration to many systems such as OpenShift, Kubernetes, and many others in the market with its APIs and set of drivers. And we managed to integrate the LinStore into LinuxONE so it can manage the LinuxONE nodes and the LinuxONE systems inside natively. And LinStore has two components. The first one is the controller, and the second one is the satellite. And the satellites are responsible for consuming the disk drives within the machines, and then creates a DRPD replicated resources for consuming by OpenShift, for example. And the LinStore controller, as the name suggests, controls the satellites, but that's it. The controller and the satellites are not in the data path. That's why the LinStore is a perfect fit for LinuxONE, because the LinuxONE doesn't want and need a bottleneck or a single point of failure. And that's why we also have the same feature. The LinStore is not sitting in the data plane. It's just a management software. And with this feature, you can easily have, you can easily upgrade, downgrade, or shut down your LinStore controllers or satellites without even touching the data. So the data will be running without any issues while you're upgrading your software, storage software, or if you lose the controller for some reason, which you can have the high availability on controller too, but let's say for some reason you lose the controller, it doesn't affect your data. And the separated data path helps you to do great data operations in your environment. And one more thing I can mention about Linbit SDS is it ties together the data availability with the replication software itself, which is DRPD, and the performance and the scale. So the LinStore is famous on performance because it's leveraging the DRPD. It's also famous on scalability because it doesn't sit on the data plane. The last one I heard about the LinStore, one of the users of LinStore is having 600 separate nodes with thousands of resources in it in one single LinStore cluster. So, and there won't be any single performance loss because of that, because the DRPD, the replication part, the data replication part of the Linbit SDS is actually doing a RAID 1 replication. It's not distributing the data over the network, over the nodes. It's just doing one-to-one replication between the machines, between the satellites. So it will give you a really performant replication performance. And Linbit SDS also really good on leveraging other technologies. So DRPD is the replication part, but we also have the deduplication from Red Hat, the VDO, the famous deduplication software in the Red Hat I think it's called virtual. Oh, I don't remember the name. Sorry. So the video is the application. I cannot remember it. Florian, give me a hand if you remember the open version of video. So we also support tiering, data locality, because we are doing this the RAID 1 replication. So you always use the data locality in the machines, and that will give you very low latency performant applications, because you're just reading from locally and only writing to the other node. And online resizing, caching, the snapshot shipping, everything is possible with LinStore, and it's all included in the package. So you don't have to do anything, and you don't have to worry about anything. Can you go one more slide, please? Okay. And the platform benefits. So we were creating partnership with IBM for so long. I mean, we were doing this for so many times, and IBM is really good on creating hardware, and while we are good creating on software. So when you combine a good hardware with a good software, you will have a platform with a lot of benefits. Okay, and one of the best benefits, obviously, that everyone is looking is the improved performance. So LinuxONE is really fast when you compare with the x85, x85 competitors. And the LiNBIT SDS is also really fast when you compare with the competitors out in the market, because most of the competitors are not using our technology, obviously, because it's ours. And they're using like data distribution, erasure coding, such kind of things. They're not bad. They're just not performant as the RBD. They have their own place. I totally agree. I mean, sometimes you need to use that kind of software. But LiNBIT SDS is the fastest software-defined storage out in the market. And lately, we actually hit the world IOPS record with LiNBIT SDS running the RBD, which was 14.8 million IOPS out of one cluster. And the closest competitor hit 13.5, I think, million IOPS. And stronger compliance. The Florian just explained us about the security part, and LiNBIT SDS is supporting all of them. And also we have encryption in granular level. So you can use the encryption in the hardware, by the hardware, or in the software as much as you like. The proven resiliency is, again, really important, just like the performance part. We want performance, yes, but we also need resiliency. That's really important. I mean, that's why LiNBIT SDS built in this mindset. So there will be zero downtime, virtually zero downtime, with using LiNBIT SDS plus LinuxONE. Because LinuxONE, the hardware built, how many seconds you said? 36 seconds per year, right? 36 seconds per year, which is most likely zero. And just like LiNBIT SDS, because LiNBIT SDS is actually replicating your data with RAID 1. So the failover times, it's nothing. It's just below seconds. And tiering needs. The tiering is important because some of your data will be hot, some of your data will be cold, and most likely you will need to use some kind of tiering mechanism in your system. And LinuxONE and LiNBIT SDS supports that, so you can have different kind of tierings in your data structure. TCO is another thing, not related with the technology, but it's related with the company, right? So everybody is looking also the TCO, the total cost of ownership, and Limbit SDS already is cheaper than the competitors, and the LinuxONE also provides a lower TCO than x86 alternatives. And when you combine these two together, obviously you will have the lower TCO when you compare with the white boxes, or I don't know, Dell machines, HP machines, whatever you have. In the
let me add something there.
Please go ahead.
So when we talk about TCO and saving costs,
Yeah.
well, those are big machines, and for sure they have some kind of cost. But as I told before, we have about a ratio 10:1, so having 10 Intel cores put on one LinuxONE core. That also has an implication on software costs that you have. For example, if you have Oracle licensing per core, well, you save just by putting your Oracle database to a LinuxONE. Well, you are saving on a ratio of about 10:1. So that is just amazing. And it also shows you, well, this is a cool platform. And what I didn't mention was, why can we do this ratio 10:1? Well, we do not have a higher frequency about 10:1. Well, we only have maybe double the frequency. But what we do is on LinuxONE, the operating system itself does really nearly no I/O, because we have an own operating system underneath that does the virtualization of the whole machine. And this operating system itself has its own processing cores, its own memory, and it does all the I/O for you. And it's just about, well, if your operating system wants something out of a disk, it does this request, it gets to the operating system underneath, and for the operating system itself, this request is now done. It's done on a separate part of the hardware, and when the data is collected, it is just an interrupt telling this operating system, well, your data is now here, and that's it. So that's also why we save so much on a TCO side, because we really nearly do not do any I/O in the operating system itself. It is done underneath.
Florian, thanks for bringing this up. So the thing is, when we talk about TCO, people always think about purchasing the machines, but it's not always, because I know from our customers all the time, just buying the Limbit SDS, for example, decrease their licensing costs. Just like you said, for example, Oracle, right? It helps you if you have the correct machine, correct software, you can decrease not just your hardware cost. You can also decrease your licensing cost. You can also decrease your CPU costs, and so on and so on. So yes, these machines are expensive, but at the end they will give you a good cost savings, right? With the platform itself. So that's really good that you bring this up. All right, the flexible deployment options is also a thing. Just like I mentioned on the earlier slide, so LinStore can scale up and scale out endlessly, and the LinuxONE also have this ability to scale up and scale out in the systems. So even if you want to go with one small machine, and then you want to grow in 2 and 3 and 4, the 4 is the limit, right, Florian, on LinuxONE? Is that the biggest machine?
Well, out of a CPU perspective, with 2 racks, this is full blown. So the 3rd and the 4th rack are only if you want more than, I think, 200 I/O cards. Then you add those racks.
Okay.
But a 2-rack configuration is the maximum for
one platform. Okay.
Yeah.
Okay.
So
great.
and those two racks are one machine.
Okay, good. Yeah. And the data and insurance. We already talked about security. We already talked about the data replication. We already talked about the resiliency. And when you combine all of these things in one platform, you will have the data insurance, obviously. And the data insurance that you can have for your critical applications and your sensitive data with the encryption and so on. And this is also a really important way if you are working in a company that is running critical applications or sensitive data. So I think I'm also done explaining the platform benefits. And the next slide should be the questions and answers, if we have any. I think I see one in the chat. Oh, he already explained that. Okay, great.
Yeah, there was this one question about, well, is it also supported for SAP HANA? Well, it is supported for SAP itself. And I had a huge customer that was running their whole landscape of SAP systems. So more than 200 different SAP systems on one machine, running in just great performance. And yeah, we are currently not certified by SAP for HANA. So that's why you currently cannot run it. So you could run it.
You could run it, but it's not supported by SAP.
It's not supported. So that's why nobody does it. So yeah.
Any other questions regarding to LinuxONE or Linbit SDS? I guess no.
I currently see no questions here.
Okay. Then I think we call it done.